welcome to Math Advice. This is Subhashini Vijayasekaran, a maths teacher. In this video, I am going to explain how to calculate mode. The most repeated value is nothing but mode. So, mode is a value that occurs most frequently. Or in other words, we should say mode is the value which has the highest frequency. So, the value repeated most is nothing but mode and the modal value. The set which has only one mode is said to be unimodal. Set with two modes are said to be bimodal. Sets which have more than two modes are said to be multimodal. Now let's see how to calculate mode for individual series. Discrete series are ungrouped frequency distribution. Continuous series are grouped frequency distribution. Let us first discuss about how to calculate mode for individual series. So for determining mode in this case, first let us count the number of times the various values repeats themselves. The value occurring maximum number of times is the modal value. This is the procedure we have to follow to identify mode in case of individual series. Let's now move on to an example and let's find the modal value. Calculate mode. In the first example, we are having a set of observations are given 320, 395, 342, 444, 551, 395, 425, 417, 395, 401, 390 and 400. Let's now count how many times each value is repeated. For that, 320 that occurs only one time. 395 repeats 3 times. 1, 2, 3. So here 395 repeats 3 times and look at the remaining values. 342 only one time, 444 one time, 551 one time, 425 only one time, 417, 401, 390 and 400. So none of the values repeated more than once except 395. So here, 395 repeats 3 times. So here all the remaining values occurring only once. So mode in this case is 395. So 395 is my modal value. Let's look at the second problem. 3675849. Here none of the values repeated more than once. All of them having equal frequency. So this is the distribution which doesn't have any mode. So mode is equal to, there is no mode because all the values are occurring only once, that is having frequency 1 each. So we don't have any mode for this series. Let us go for the next problem. 25 repeats, and just write down here. So value and frequency. So 25 that repeats 1, 2 and 3. So 25 repeats 3 times. The next 32. 32 repeats 1, 2, 3. 3 times. And 24. 1, 2 and 3. 24 also repeats 3 times. And 27 1, 2 and 3. So 3 times. So here each value that is repeated 3 times each. So this is also an example of a distribution or series doesn't have any mode, because all of them is repeated equal number of times, that is having equal frequency. So this is a distribution which doesn't have any mode. So we don't have any mode for this case. Let's go for the next one. 0, 2, 5, 6, 9, 5, 6, 14, 6, 15, 5, 6, 5. So here 0 occurs only one time, 2 occurs once, whereas 5 occurs 1, 2, 3 and 4 times. Likewise 6 occurs 4 times. So let's write down as usual value and frequency. 0 occurs 1 time, 2 occurs 1 time, and 5 occurs 4 times, and next 6. 6, 1, 2, 3 and 4. 6 also repeats 4 times. Remaining 9, 4, 15 all are repeats only once. So 5 and 6 having the maximum frequency. So mode in this case is 5 and 6. So this is an example for a distribution having 2 modes. This is a bimodal distribution. So this it is having 2 modes, 5 and 6. Both of them repeats 4 times each. Let's now move on to how to calculate mode for discrete series or ungrouped frequency distribution. Here the mode can be determined in 2 ways, that is by inspection and by the method of grouping and analysis table. We have to identify the mode. Determine mode. Here the values and frequencies are given, that is 18. The value 18 repeats 55 times. Here the value 20 repeats 120 times, 22 repeats 108 times, 24 repeats 45 times. That is the meaning of frequency. Okay. So let's now look at the highest frequency here. So 120 is the highest frequency, and the corresponding value is the modal value. Also here the distribution is regular, so mode here is 20. So mode is the value that corresponds to the highest frequency. Here the highest frequency is 120, the corresponding value is nothing but 20. So 20 is the modal value. Let's move on to the next problem. Find the modal size. Here size of shoes and number of pairs sold is given. Shoes size are from 3, 4, 5, 6, 7, 8 and 9. In corresponding number of pairs sold are given here as 10, 25, 32, 38, 61, 47 and 34. So look at the highest frequency here. Also here the distribution is regular and the highest frequency here is 61. The corresponding value is the mode. Here modal size or mode is equal to 7. So mode is a value that corresponds to the highest frequency. If the distribution is regular, here in both of the cases we have to identify mode by inspection method. We just look at the highest frequency and write down the corresponding value as the mode. Yeah. Let's now move on to the next problem. Here the values and corresponding frequencies are given. Values are from 10 to 18 and corresponding frequencies are also given. So here just look at the highest frequency here. Highest frequency here is 20. Also here the distribution is not regular. In the previous two cases the distribution is regular and we have to identify mode by inspection method. But in this case the distribution is not regular because the highest frequency is 20 and the next two highest frequency is 19, which is closely related to 20. So we couldn't identify the modal value by inspection. That is the difference between the highest frequency and the next two highest frequency is very small. That is, it is heavily concentrated on either side. And also the distribution is not regular, so we couldn't find out the modal value by inspection. That is, we couldn't say 14 is the modal value. So for that, what we are going to do is, we have to use the grouping and analysis table to find out the mode in this case. The method of grouping is used in this. Now, under grouping table, we have to first write down the values and corresponding frequencies. That is frequency that is given in our problem. We have to write down in the first and second column. Grouping table consists of 6 columns. Here, frequency is its first column, and then 2, 3, 4, 5 and 6. So under second column, what you are going to do is, you just add the frequencies in twos. That is F1 plus F2. That is, this is the first frequency, second, third frequency, fourth frequency. So like that I have to use the suffix F1 plus F2 to denote the first and second frequencies. So you have to add first and second frequencies, that is 10 plus 12. While adding and writing the value of 10 plus 12, you just write it in the center of 10 and 12 like this. Okay. Then add 15 plus 19. 15 plus 19, that is to be written in the center of these two values, that is 15 plus 19. Then 20 plus 8. I have to write it in the center of 20 and 8. So 4 plus 3. 4 plus 3. We don't have any values for 2. That is, we don't have any pair for 2. So just leave it. On to column 3. So in column 3, we just omit the first frequency. If you leave the first frequency, let's start with F2. F2 plus F3. That is, add the remaining frequencies in twos. Add 12 plus 15. While you add 12 plus 15, you get some value. So you just write it in the center of 12 and 15. Then 19 plus 20. That is to be written in the center of 90 and 20 approximately. Okay. So 8 plus 4. Then 3 with 2. Then under column 4, we have to add the frequencies in threes. That is, add the frequencies F1 plus F2 plus F3. So you have to add the frequencies in threes. Add 10 plus 12 plus 15. You just write it in the center. That is, center of these three values nothing but 12. So we have to write the values in the center of 12. Next, add, so 19 plus 20 plus 8. Then 4 plus 3 plus 2. 4 plus 3 plus 2. Under column 5, omit the first frequency and add the remaining frequencies in threes, that is F2 plus F3 plus F4. You have to add 12 plus 15 plus 19. Then 20 plus 8 plus 4. So since we are having only two values, just leave it. So under column 6, just leave the first two frequencies and add the remaining frequencies in threes, that is F3 plus F4 plus F5. That is 15 plus 19 plus 20. Then 8 plus 4 plus 3. Now we have to add the values. 10 plus 12, we get the total as 22. Then 15 plus 19, we have 34. Then 20 plus 8, we have 28. Then 4 plus 3, we have 7. Then 12 plus 15, we have 27. Then 19 plus 20, we have 39. Then 8 plus 4, we have 12. Then 3 plus 2, 5. And then 10 plus 12 plus 15, we have the total of 37. Then 19 plus 20 plus 8, we have a total of 47. Then 4 plus 3 plus 2, we have 9. Now under 5, we have 12 plus 15 plus 19, that is 46. Then 20 plus 8 plus 4, we have 32. And then 15 plus 19 plus 20, we have 54. And then 8 plus 4 plus 3, we have 15. Now we have finished the grouping table. Now let's complete the analysis table. For that, let's now circle the highest value under each column. So under column 1, we have the highest value here is 20 is the highest value. Under column, so 20 corresponds to 14, and just put 1 under column 1 against 14. Then in 2, I have the highest value here is 34 is the highest value. This is obtained by adding 15 and 19, and 15 and 19 corresponds to 12 and 13. 15 and 19 corresponds to 12 and 13. So under column 2, I put 1 against 12 and 13 in analysis table. Then in column 3, the highest value here is 39. 39 is the highest value. It corresponds to 90 by adding 19 and 20. By adding 19 and 20, I get 39. 19 and 20 corresponds to 13 and 14. So, I just put 1 against 13 and 14 under column 3 in analysis table. Now, under 4, the highest value here is 47. 47 is obtained by adding 19 plus 20 plus 8. That is adding 19 plus 20 plus 8. I get 47. So these three values corresponds to 13, 14 and 15. So I am just put 1 against 13, 14 and 15 under column 4 in analysis table. Then under column 5, since we are having only two values, so between this 46 is the highest value. This is obtained by adding 12, 15, 19. This by obtained by getting 12, 15 and 19. These three corresponds to 11, 12 and 13. I am just put 1 against 11, 12 and 13 under column 5 in analysis table. Now under 6, 54 is the highest value. This is obtained by adding 15, 19 and 20. This corresponds to 12, 13 and 14. So I am just put 1 against 12, 13 and 14 under column 6 in analysis table. Now we just add the total. 10 that doesn't have any value, just leave it. Whereas 11 have only 1. Whereas 12 have 1, 2, 3, 3 ones. So totally 3. Whereas 13 have 1, 2, 3, 4, 5. 5 ones. 14 has 1, 2, 3, 4. 15 has only 1. 16, 17, 18 doesn't have any value. Here, you just look at the highest value. So, 5 is the highest value. It corresponds to 13. So, the mode value here is 13. 13 is the modal value in this case. Let's now move on to how to calculate mode for continuous series or grouped frequency distribution. So here we have to follow certain rules to calculate the mode. If the class intervals are in ascending order, continuous and the size or length of the class intervals are equal, then only we have to follow the steps to calculate the mode. So first we have to identify the modal class interval either by inspection method or by preparing grouping and analysis table. So the calculation of mode is done by two ways. One by using interpolation formula. So if the class interval with the greatest frequency is identified as a modal class interval, then we have to use this formula. That is mode is equal to L plus Fm minus F1 over 2Fm minus F1 minus F2 into H. Here L represents the lower limit of the modal class, H represents size or width of the modal class, F1 is the frequency of the class preceding the modal class, Fm is the frequency of the modal class and F2 is the frequency of the class succeeding the modal class. Whereas in case 2, if the class interval other than the one with the greatest frequency is identified as the model class interval by grouping an analysis table, then apply this formula, that is mode is equal to L plus F2 over F1 plus F2 into H, whereas L, H, F1 and F2 have the usual meaning, that is L represents the lower limit, as H represents size or width of the model class, F1 is frequency of the class preceding the model class, and F2 is the frequency of the class succeeding the model class. Let's now move on to the problem. Calculate the mode. Here the class intervals and corresponding frequencies are given. Class intervals are from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. And corresponding frequencies are 12, 18, 27, 20, 17 and 6. Let's first check whether the class intervals are in ascending order, continuous, and the size or width of the class intervals are equal. Here, the class intervals are continuous, that is, there is no gap between one class intervals to another. So the class intervals are continuous, and also in ascending order, because 0 to 10, 10 to 20, so that is an increasing order. So those are given in terms of ascending order. Then the size and width of the class, all the class intervals having 10, that is the width of the class intervals are 10 equal. So we have to proceed to calculate mode. Now look at the values given here. Here the distribution is regular, because here the highest frequency is 27. Since the distribution is regular, the model class would be the class having the highest frequency. So here the highest frequency is 27, and also the distribution is regular, so we have to identify the mode by inspection method. If the distribution, so listen carefully, if the distribution is regular, you have to identify the mode by inspection method. You just look out the highest frequency and write down the corresponding value or corresponding class interval as the model class interval. Suppose if the distribution is not regular, you couldn't identify the mode by inspection method, then only we go for the grouping and analysis method to find out the mode. So the model class, highest frequency here is 27. Model class of the given frequency distribution is 20 to 30. Is a model class. If the class interval with the greatest frequency is obtained as a model class, so we have go for the first formula. 20 to 30 is the class interval having the highest frequency 27. So we make use of the first formula to calculate mode, because 27 is the highest frequency in this case. So we go for the first formula in this case. So mode is equal to L plus F1 minus F1 over 2F1 minus F1 minus F2 into H. That is here L. L is the model classes, 20 to 30 is my model class. So here L represents lower limit of the model class. So 20 to 30 is my model class. So L represents lower limit of the model class. So lower limit of the model class is 20. Since 20 to 30 is my model class, so 20 is the lower limit and 30 is the upper limit. I need only the lower limit. So 20 is the value of L. Age, size or width of the model class. So each of the class interval having equal size, that is 10. That is the 10 difference between one class interval to. So age is 10. F1, frequency of the class preceding the model class. This is the model class. So it has F1 is the frequency of the class preceding the model class. So this is the preceding value, frequency value. So F1 is $18. Then Fm, frequency of the model class, that is 27. Then F2, frequency of the class, that is of the class succeeding the model class. So 20 is the succeeding model class frequency. So 20. So we have all the values. Let's now calculate the value of mode. So mode is equal to L. So we have the L value 20 plus Fm is 27 minus F1 is 18 divided by 2 into Fm. Fm is 27 minus F1 is 18 minus F2 is 20 into H. H value is nothing but 10. So 20 plus 27 minus 18 is 9 over 2 into 27, that is 54 minus 18 minus 20 into 10, that is equal to 20 plus, when you multiply 9 with 10, we have 90 over, when you subtract 54 minus 18 minus 20, we have 16. So that's equal to 20 plus, while you divide 90 by 16, we have 5.625. While we add this with 20, we have 25.625. So mode in this case is, so mode is equal to 25.625. So you have to cross check the value too. Since we are getting the model class as 20 to 30, always the mode value lies within the model class interval. So the value 25.625 lies between 20 to 30. So our calculation value is correct. So this is how we have to cross verify whether the value of mode you have calculated is lies within the class interval or outside the class interval. That always lies within the model class interval. So mode is equal to 25.625 in this case. Let's now move on to another problem. Here marks and number of students are given, but look at the values here. So what are the steps we have to proceed before calculating modus? We just find out whether the class intervals are continuous and ascending order, and there is an equal size or equal width between the class intervals. These are the cases we have to discuss before we have to move to calculate mode using any of the two formulas. So first we have to check the 3 points, whether the class intervals are in ascending order and the class intervals are in continuous, and also that is what is the size or width of the class intervals. Now the class intervals here are ascending order, that is start with 30 and are increasing gradually, but that is not continuous because there is a gap between one class interval to another. And also look at the size or width of the class interval, all of them having 4. The difference between the size of the class interval is 30 to 34, that is 4 difference. 35 to 39 we are also having with a 4 difference. So the size is equal. So what you are going to do here is we just want to convert the class interval to continuous. Then we move to calculate the mode. Write down the value of marks and number of students. I am just leave one column in between because I am just fill up the continuous class intervals here. 30 to 34, 35 to 39, 40 to 44, 45 to 49, and 50 to 54, 55 to 59, and 60 to 64. Then how to convert the class intervals as continuous class interval? We just follow the small procedures, and number of students here are 3, 5, 12, 18, 14, 6 and 2. So you just look at the difference, that is what is the gap between one class interval to another. 34, 35, that is one gap. So all the class intervals having one gap. You just take a half of the difference. So one gap. So and you just divide this by 2. If you divide that by 2, you have 0.5. What you are going to do here is you just subtract 0.5 from all the lower class intervals and add 0.5 with all upper class intervals. When you subtract 0.5 from all the lower class intervals, 30 minus 0.5 is 29.5. Then 35. If you reduce 0.5 from 35, you have 34.5. And 40. If you reduce 0.5 from 40, you have 39.5. Here 45 minus 0.5, 44.5. 49.5, 54.5 and 59.5. That is, you have to subtract 0.5 from all lower class intervals. Then, how to balance this is, you just add 0.5 with all upper class intervals. Just add 0.5. So if you add 0.5, 34 plus 0.5, 34.5. 39 plus 0.5, 39.5. 44 plus 0.5, 44.5. 49 plus 0.5, 49.5. 54 plus 0.5, 54.5. 59 plus 0.5, 59.5. 69 plus 0.5, sorry, 64 plus 0.5, 64.5. So now the class intervals are in ascending order, continuous, and also the size or width of the class intervals are equal. So now let's look at the marks and number of students to find the modal value. Here the distribution is regular. Since the distribution is regular, so the modal value can be identified by inspection. So the modal class interval as identified by inspection method. So now look at the highest frequency here. 18 is the highest frequency. 18 is the highest frequency in the corresponding modal classes 44.5 to 49.5. Here 18 is the highest frequency and its corresponding modal classes 44.5 to 49.5. Then we make use of the formula mode is equal to L plus Fm minus F1 over 2Fm minus F1 minus F2 into H. Here the modal classes we have the modal class 44.5 to 49.5. Now, L represents the lower limit of the modal class. Lower limit is 44.5 is the lower limit. H is nothing but size or width of the modal class. So now here size of the modal class is 49.5 minus 44.5, that's equal to 5. That is, when you make the difference between upper and lower limit of the class interval, you get the size. So here the size is 5. And frequency of the class preceding the modal class, F1. So F1 is the frequency of the class preceding the modal class. This is your F1. F1 is 12. Then Fm. Fm is frequency of the modal class. Here the frequency of the modal class is 18. Then F2. F2 is frequency of the class succeeding the modal class. Frequency of the modal class succeeding the, frequency of the class succeeding the modal class, that is 14. So our F2 is 14. So mode is equal to L plus, that is 44.5 over Fm, that is plus 44.5 plus Fm minus F1. F1 is 12 over 2 into Fm minus F1, that is 12 minus F2, that is 14. Into H, that is 5. That's equal to 44.5 plus, when you subtract 18 with 12, we have 6 over When you multiply 2 with 18, we have 36 minus 12 minus 14 into 5. So that's equal to 44.5 plus, when you multiply 6 with 5, 6 into 5, we have 30 over, when you subtract 36 minus 12 minus 14, you have 10. So that's equal to 44.5 plus, when you divide 30 by 10, you have 3. When you add 3 with 44.5, you have 47.5. So mode is equal to 47.5. That lies within, this is our modal class interval 44.5 to 49.5. Our modal values also lies within the modal class. So mode is equal to 47.5. Let's now move on to another problem to calculate mode. Here the marks and its frequency is given. Here the marks and frequencies are given. So as usual, we have to check whether the class intervals are in ascending order. So here the class intervals are in ascending order and also continuous. The size or width of the class intervals all are here are equal. So we have to proceed to calculate as on procedure. You just look at the highest frequency here. 31 is the highest frequency, corresponds to the class interval 40 to 50. But the distribution is not regular. Since the highest frequency is 31 and the next to highest frequency is 30, and the difference between these two is very small, and also it is heavily concentrated on either side, so you could find the modal value just by inspection method. So the distribution is not regular. The modal class can be identified by the method of grouping. That is, we go for the grouping and analysis table to calculate to find the modal class first and then calculate the value of mode using the formula. Discussed in case of discrete series, here itself you have to write down the class interval in the first and second column, class interval along its frequency as its first and second column. Then under column 2, you have to add the frequencies in 2's, that is F1 plus F2. If you add the frequencies in 2's, 7 plus 15, you just add the values and write it in the center of 7 and 15. Like that, 18 plus 13, you just add these two values and write it in the center. In column 2, like that, 31 plus 4 and then 3 plus 1. In column 3, you just omit the first frequency and add the remaining frequencies in 2's. That is, omit a first frequency, you just leave it and add 15 plus 18 and write it in the center of 15 and 18. Like that, add 30 with 31 and then add 4 plus 3. Whereas in column 4, you have to add the frequencies in 3's, that is, add the frequency as F1 plus F2 plus F3. that is 7 plus 15 plus 18, then 30 plus 31 plus 4. Since we are having only two values, just leave it. On 5, leave the first frequency and add the remaining frequencies in threes, that is F2 plus F3 plus F4. Leave the first and add remaining in 3. Since you are having only one frequency, you just leave it. That is 15 plus 18 plus 30. 31 plus 4 plus 3. In column 6, you just leave the first two frequencies and add the remaining frequencies in threes. That is F3, F4, F5. You just add the remaining frequencies in threes. 18 plus 30 plus 31, then 4 plus 3 plus 1. Now we have to add the values. Now we have to add values. By adding 7 with 15. Sorry. Add 7 with 15. We have 22. 18 plus 30. We have 48. Then 31 plus 4. 35, 3 plus 1, 4, 15 plus 18, 33, 30 plus 31, that is 61, 4 plus 3, that is 7. 7 plus 15 plus 18, that is 40. 30 plus 31 plus 4, that is 65. 15 plus 18 plus 30, we have 63. 31 plus 4 plus 3, we have 38. And 18 plus 30 plus 31, we have 79. 4 plus 3 plus 1, we have 8. I have calculated all the totals in grouping table. Next, let's move on to analysis table. For that, let's now circle the highest frequencies in each column. In column 1, 31 is the highest value corresponding to 40 to 50. So, I am just put 1 against 40 to 50 in column 1 in analysis table. Then, in column 2, 48 is the highest value. 22, 48, 35, 4. 48 is the highest value. That is obtained by adding 18 with 30. It corresponds to 20 to 30 and 30 to 40. I am just put 1 against 20 to 30 and 30 to 40 in analysis table under column 2. Whereas in column 3, 33, 61, 7. 61 is the highest value, obtained by adding 30 and 31, corresponds to 30 to 40 and 40 to 50. Under column 4, 40, 65. 65 is the highest value, that is obtained by adding 30, 31, 4. So that is 30 to 40, 40 to 50 and 50 to 60. 30 to 40, 40 to 50 and 50 to 60. I am just put 1 against all this class interval under 4 in analysis table. Under column 5, 63, 38. So 63 is the highest value obtained by adding 15, 18, 30. So corresponds to 10 to 20, 20 to 30, 30 to 40. 20, 20 to 30 and 30 to 40. Then under column 6, 79 and 8. 79 is the highest frequency obtained by adding 18, 30, 31. It responds to 20 to 30, 30 to 40 and 40 to 50. So 20 to 30, 30 to 40, 40 to 50. So that's all. Now let's add. 0 to 10 doesn't have any value. Here 1, 3, 1, 2, 3, 4, 5, 40 to 50, 1, 2, 3, 4, 1. So look at the highest value here. Highest value of 5 that corresponds to 30 to 40. So the highest value here is 5 responds to the class interval 30 to 40. So the model class is 30 to 40. So our model class is 30 to 40. Look at here, interval 30 to 40 having the highest frequency density. So we make use of the formula mode is equal to L plus F2 over F1 plus F2 into H. Because here you make use of the second formula. Because 31 is the highest frequency, but by method of, since the distribution is not regular, since by the method of grouping, using the method of grouping we have obtained 30 to 40 is the model class interval. Having the 40 is the model class. This is the class interval having the greatest frequency density, even though it doesn't have the greatest frequency. So we make use of the second formula. Here L represents lower limit of the model class. So 30 to 40 is my model class. So 30 is the lower limit. H is the size of the model class, that is 10. Frequency of the model class preceding the model class, that is 18. And F2 is the frequency of the class succeeding the model class, that is 31. So we calculate the value of mode now. So mode is equal to L is 30 plus F2, that is 31 over F1 plus F2, 18 plus 31 into H. So that's equal to 30 plus, when you multiply 31 with 10, we have 310 divided by, when we add 18 plus 31, we have 49. So this is equal to 30 plus, when we divide 310 by 49, we have 6.3. When you add 30 with 6.3, we have 36.3. So our mode is equal to 36.3. That lies within the model class. 30 to 40 is my model class. So the model value lies within the model class. This is how we have to check whether the model value lies within the model class interval or not. Definitely it should lies within the model class. So the mode of the given problem is 36.3. cross check what happened if we choose the wrong formula. What happened if we choose the wrong formula in this case? Okay. So in this problem, 30 to 40, 40 to 50. So here the model class is 30 to 40. So instead of choosing the second formula, if we choose the first formula, that is interpolation formula, what happens? What will be the answer for this problem now? That is, now we are going to see. So L is the lower limit of the model class, that is 30. H is the size of the model class 10. Frequency F1 is the frequency of the class preceding the model class, that is 18. And Fm is frequency of the model class, that is 30. This is my Fm. And F2 is the frequency of the class succeeding the model class, that is 31. So mode is equal to L. Lower limit is 30 plus Fm. 30 minus 18 over 2 into 30 minus 18 minus 31. So into H is width of the class interval 10. So that is equal to L 30 plus, when you subtract 30 minus 18, we have 12 over, when you multiply 2 into 30, you have 60 minus 18 minus 31 into 10. That's equal to 30 plus, when you multiply 12 with 10, you have 120 over, when you subtract 60 minus 18 minus 31, you have the total as 11. That is 30 plus 120 over 11 is equal to 10.9. When you add 30 with 10.9, .9. This is my mode value. But our model class is 30 to 40, but my model value here I have obtained is 40.9. That doesn't lies within the model class. So the formula is not applicable, because here 31 is the highest frequency. If the class interval with the highest frequency is identified as the model class interval, then only you make use of this formula. If the class interval other than the one with the highest frequency is identified as a model class interval, you make use of the second formula. Suppose if you choose the wrong formula like this, you get the mode value that doesn't lies within the model class. That represents the formula is not applicable. Then you go for the next formula to calculate the mode. So hope you got a clear idea about how to calculate mode for all types of series. Thanks for watching. See you again in my next video.